Hey, my friends, we're back at it again. We're in Venn diagrams part 2. Now, you can immediately see that now we've gone from 2 sets to 3 sets. We'll never go any higher than 3 sets in Math 30-2. And you would think, oh, this is going to make things a heck of a lot more complicated, but it's actually not. It's as long as you understand how everything was working with the first 2 sets, you'll be just fine here. There's nothing too new or radical with what we're doing here. Okay, let's give a couple of these a try. So in each of the following Venn diagrams, shade the indicated region. Okay, A and B. Now, what I'm going to do first is wrong. A lot of students go, okay, I'm in A and B the first time they do this. So they would only shade this little region there. And I partially agree. I say, yeah, those are definitely, anything that's in that shaded region are elements that are in A and B. But what I really need you to recognize right off the bat is so is this shaded region in red. Those are things that are elements that are also in A and B. Yes, they may be in set C as well, but that doesn't matter. They've satisfied the condition that they are in A and B. So as long as it's in A and B, it doesn't matter if it's in something else. I need to shade it. Okay, A or B. Well, A or B, same as last time. I'm in A, or I'm in B, or I'm in both. So there's A or B. That usually doesn't get anyone into any trouble. That's a pretty simple one. Okay, the next one, A and not B. A and not B. So I'm the elements in A, but I'm not in B. So I'm in A. There's A, but I'm not in B. I'm not in B. Well, where's B? So I don't want to be in B. So I'm not going to include this little region right there. So A and not B. The other way to say that is only A. A only. The elements that are in A only. So I'm only looking at this region right here. This moon-looking region in green. That is the only region I'm looking at. A only. Maybe I will just highlight that one more time, just like that. A only. A and not B. Okay, last one here. A and not B and not C. Well, that's a mouthful. Well, maybe let's see if we can say that in a different way. I'm in A, I'm not in B, and I'm not in C. Well, that means I'm in A only again. A little bit easier to write that way, isn't it? And that's us right there. A only. Okay, so sometimes the way these things are written, it's nice to rewrite them in a better way, simpler. Okay, so just because there's 3 sets doesn't matter too much. Everything stays the same. Okay, the Venn diagram on the right displays a survey of Ahundi families regarding technology in their homes. Okay, C represents the number of families with a computer. D is DVRs, S is scanners. Okay, here we go. So notice it's nice when they give us the Venn diagram. Okay, so there's my universe. There's Ahundi people, computers, DVRs, scanners. Okay, so what percentage of families have a computer at home? Okay, well, computer at home, there's 78 out of 100, so 78%. How many families have all 3 machines in their home? Okay, well, all 3 machines would be the triple intersection. So what that would be, that's 5% or 5 of them. But what I want you to think about is maybe let's start writing this out in notation. That would be C intersect D intersect S. It's the intersection of all 3 sets. The first one simply just would have been C. How many people have a computer? I'm set C, 78. How many of the families have none of the machines? Well, none of the machines, these people on the outside, 3 or 3%. Now, what would that be if I was using set notation? Well, those are the people that don't have a computer or a DVR or a scanner. So I'm going to write it like that. Remember, there's that little prime. That means not. So that would be not a computer or a DVR or a scanner. Okay, I really want you practicing writing these things with set notation if you can. How many families do not have a scanner machine? Well, I'm going to go ahead, I'm going to highlight scanner. So here's scanner. Those are the people that own a scanner. So I want all the people that do not own a scanner. So that's everyone on the outside. So again, there's more than one way to do this. Some of you will do this in a slightly different way, but as long as we get the same answer. So not a scanner, not a scanner, S prime. So all I'm going to do is I'm just going to add up all those numbers. 7 plus 62 plus 18 plus 3. What is that? 80 should be 90, which makes sense because the other way to do this question is to say, hey, look at right here. There's 10 people that have scanners. Well, if S is equal to 10, then what I know is the complement of S, S prime, has to add up to the universe, which is 100 minus 10, 90. So there's more than one way to do these questions. One answer. How many families have a computer and a DVR? Okay. How many have a computer and a DVR? So computer and a DVR. So computer and a DVR. So make sure that we're including the 5 there. So this would be computer and DVR. So that's 62 plus 5. Again, the people that have the 5 have all 3 devices, but they certainly have then a computer and a DVR. They fit that condition. So we say 67. Now, it's nice when they give us the diagram. The only other thing I can really ask you to do here is go the other way around. Can you draw the diagram for me? That's the hardest question I'm going to give you. Okay, so let's keep going here. Let's see if we can draw this one. So again, the max, as soon as I see it, the max is 3. This is standard of excellence because there's 3 sets. So we got a sports club. Every member plays at least one sport. So that means there's no one outside the 3 sets. And we're playing soccer, rugby, or tennis. And then they list all these different conditions here. Now, if I can, I'm always going to start at the intersection. So it says 4 play all 3 sports. Bang. Now, once I've done that one, I want to go and see if I can find one of these other intersection regions. So let's just go through. Every question's a little bit different. Let's see what else we can find. So it says 43 play tennis. Okay, I'll just write that right there. Okay. Then it says 11 play tennis and rugby. 11 play tennis and rugby. So where's that? Well, tennis and rugby is this black region right here. So that highlighted black region I just put there, there's 11 people in that region. So watch this part carefully. This is the #1 mistake. I'm about to do this wrong on purpose for once. This is wrong. I'm going to change it to bright red so you know it's wrong. Do not tell me that this is 11. That is wrong. That would tell me right there that there's 15 people who do tennis and rugby. That's wrong. There's 11 people that play tennis and rugby. So let's fix it. That is the #1 mistake, by the way, right there. When you goof up on a test, that's the first place every teacher is going to look. What I know is there's 11 people who do tennis and rugby. Well, if 4 of them do both, guess what? That means 11 minus 4 is 7. There's 7 people who do tennis and rugby only. Okay, so that is the number one mistake. Let's keep going. 7 play tennis and soccer. So 7 play tennis and soccer. Tennis and soccer, right there. Well, that says there's 7 people that do that. So what that means then is 7 minus 4 is 3. There's 3 people that play tennis and soccer only. So do you see every time we need to subtract? Okay, 6 play soccer and rugby. So again, I'll highlight it. It's nice and easy for me to do. There's 6 people that play soccer and rugby. So again, I need to subtract. That means there's 2 people right there that play soccer and rugby only. Let's keep going. 84 play rugby or tennis. Okay. 84 play rugby or tennis. Well, where would that be? Rugby or tennis? Well, I'm highlighting in pink here. There's my 2 regions. I know that's 84, but look at it. I got this region here, and I got this region here, rugby only and tennis only, and I don't know how to find those. I don't have those numbers. But I haven't used, there's 43 people that play tennis yet. So maybe let's see if we can use that first. So how's that going to help us? Well, if I know there's 43 people that play tennis, that's this whole circle right here. So how's that going to help me? Well, I know this region right here is tennis only. So I'm going to go 43, subtract 7, subtract 3, subtract 4. The kids tell me that's 29. Now, that's tennis only. So what am I going to do with that? Well, now what I'm going to do with that is now 84 play tennis or rugby. So what I know now is that these 2 sets I've highlighted in pink, I know these 2 sets have to add up to 84. So I'm going to go 84 minus all these other numbers that I've got highlighted inside the pink regions. And I'm going to play it safe. I'm actually going to go 84 minus 43 minus 2, which is 39. So there should be 39 people in here. Now, I'm going to stop and take a second. I don't have a good way to check my work in this unit, but what I'm doing right now is I'm adding up all those numbers that are in the 2 pink circles and making sure they add to 84. They do. Guess what? I'm getting this question right. Okay, just get rid of these 2 circles. Boom. Okay, last one here. What have I got? Let's go to pretty maroon. I've got 68 that play soccer or rugby. So soccer or rugby. So I'm going to highlight that. There's the people that play soccer or rugby. So those 2 added up together add up to 68. So this region here, soccer only, I'm going to subtract all these numbers. So I'm going to go 68 minus 39 minus 7 minus 4 minus 2 minus 3. That's going to give me 13. And my final check. It says everyone plays a sport. So that means there's no one out here. Everyone's playing a sport. We're at the National Sports School or something. Everyone's playing a sport. Well, let's do a final check. Let's see if this adds up to... Oh, we don't know what it adds up to, so we can't do a final check. Part B, what I was going to do for my check, silly Mike, is I was going to add them up to see how many members the club has. Well, that's actually the question I'm supposed to answer. So let's add these all up. 29 plus 7 plus 4 plus 3 plus 39 plus 2 plus 13. Looks like there's 97 people in this club. Boom. Okay, C. Ooh, how many elements, how many people in the region, wow, that looks ugly, R intersect not T union S. Okay, R intersect not T union S. Ugly. Okay, let's figure this one out. So I'm going to do some highlighting here. So T union S, again, what I'm going to do for a second is I'm going to pretend that prime isn't there. So T union S. T union S. There's T union S. Now I want not T union S. So I'm reintroducing the prime, not T union S. So I want everything outside T union S. Like that, right? So that's the first part right here done, T union S. But then I've got this other piece to worry about. It says R intersect this. So where does R intersect this pink shaded region? Right there. Right there. Answer is 39. Well, what does this mean? Answer is 39. There's 39 members there. What does this mean? This really, what this is saying is I play rugby and not tennis or soccer. I play rugby and not tennis or soccer. Well, really, that's just rugby only, right? I only play rugby. Boom, done. So a couple different ways to do it. The first way I did it was I just used the set notation. The second way to do it is maybe just to break it down into a sentence. Just think about it logically. What is this question actually telling me? 39 people play rugby only. Okay, this is again a standard of excellence question. This is considered a difficult question in this unit. So if you're following along, you got this. Okay, if not, that's okay. Guess what? We got lots of practice to do as always. Okay, let's try just a couple more. Okay, the Venn diagram to the right says that there's a survey of 100 students, and we got a cell phone, a computer, and a DVD. So how many people own a cell phone only? Cell phone only. Well, cell phone only is right here. No, it's not. Cell phone only is T. I'm a liar. Cell phone only. Right here. Okay, so 17. How many students own a cell phone? Well, that changes the question. Own a cell phone would be this whole circle. So that would be 17 plus 1 plus 6 plus 2, 18, 24, 26. I don't know when this survey was done, 1995. I'm sure the answer now would be 99, right? How many students own a computer and a DVD? Computer and a DVD. So computer and a DVD, that region right there. 7. How many students own a computer or DVD? Computer or DVD. So computer or DVD, union, we're getting bigger. So I'm going to add all these numbers up. Well, the other way I'm going to do this, just to make my life a little simpler, is I know there's 100 students in this survey, so I'm going to use the complement. 100 minus the people that do not own these. So that should be 81. Or you just add up the numbers in your circle. Same, but different. E, what does this ugly region here? D intersect not T union C. Oh, okay, so what does this say here? Not T or C. So I do not own a computer or a cell. Okay, and the first part here says DVD. So I own a DVD and I do not own a computer or a cell phone. Well, that's a long, convoluted way of saying I only own a DVD player. So what am I really looking for here? DVD player only. Bang, 3. Okay, last one. How many students own a computer or a DVD? Own a computer or a DVD, but do not own a cell phone. Computer or DVD, but do not own a cell phone. Right there. So that would be 3 plus 1 plus 68. That sounds like 72 to me. Okay. So computer or DVD, but not a cell phone. Should be 72. Okay, not too bad. Okay, I think the trickiest question there was E. That notation's ugly. Okay, last question. Last question. Number 5. Okay, so we got a book club and we're reading 3 different genres of books. And we got a few questions to answer from here. So, first question. Fantasy or mystery, but not adventure. Fantasy or mystery, but not adventure. So, fantasy or mystery, but not adventure. Okay. So that's going to be 9 plus 1 plus 8. Sounds like 18 people. B. How many are in F union M intersect A? So that is fantasy or mystery. Fantasy or mystery and adventure. So here's fantasy or mystery. Right here, right? There's fantasy or mystery. But now I want the people who and like adventure. So where's the intersect? And adventure. I'm looking right there. Good. Last couple. Adventure or fantasy, but not mystery. Adventure or fantasy, but not mystery. Well, there's fantasy. There's adventure, but they can't like mystery. There it is. 17. 9 plus 1 plus 7. And last one, let's go for pretty pink to finish the day. Not F and M. So you know by now what I'm going to do, don't you? I am going to cover up the prime. I'm going to pretend it's not there. F and M. There's F and M. So now I reintroduce the prime. I reintroduce the not. And I say not F or M. Well, guess what? It's going to be everything on the outside of that, right there. Not F and M. And a lot of numbers to add up here, unfortunately. Not F and M. Let's see if we got this to finish this one off. 9 plus 1 plus 7 plus 4 plus 8, 10, 21. Sounds like 29 students. Okay, there it is. So what you can see I'm trying to get you to practice here is using words and notation. It's very important that you can become a little bit flexible and do it in both ways. Okay, my friends, that's it. That's Venn diagrams part 2 with 3 Venns. Remember, we don't go any further than 3. That's as difficult as it gets. See you next time. Hope you're doing well.